Okay, so we're going to do something called linear programming, and this is going to be kind of the intro to linear programming. Linear programming is actually it's actually word problems where you solve by graphing inequalities and trying to find minimum, maximum values for a different function than any of your inequalities. That usually is around profits. It's kind of a technique that's used a lot in economics and in business. And this kind of program is this kind of linear program we can do by hand, and when you end up doing them in business, the graphs get way too complicated and you end up having to have a computer do this work for you. But I've given several definitions here of linear programming. We'll see them in work tomorrow. But for right now, we're going to kind of use the end technique, the solving technique that we'll do when we do our linear programming, where we graph some inequalities, which are our constraint functions. And then we will have an objective function that we will be looking at to find a minimum or maximum value or profit or something like that. Okay, so here we go. We have a set of inequalities. We're going to graph those inequalities, and then we're going to look at the shape made by the inequalities, and then um, look at the corners of that shape and test the corner points in our profit or our objective function, which is this one right here, our p function. Sometimes it'll be p, sometimes c, they'll give it different names. Okay, so first off, I'm going to graph these inequalities. First, x is less than or equal to 5. X is less than or equal to 5 is as a vertical line at x equals 5, and I need it to be solid, don't I? 1, 2, 3, 4, 5. That's pretty close. Okay. Y less than or equal to 4 is a horizontal line at 4. 1, 2, 3, 4. Let's see if I can do a little better on this. I did. And then when I think less than or equal to 5, I'm thinking to the left of the 5. When I'm thinking less than or equal to 4, I'm thinking below the y equals 4. And now I'm thinking x greater than or equal to 0. So that is a vertical line at 0. And y greater than or equal to 0, that's going to be a vertical line on the x-axis. So that gives me the less than 4, the less than 5, the greater than 0, the greater than 0 gives me this little shaded area right here. Okay, now I got to go looking for the vertices of this polygon is what we make. Okay, upper leftmost vertex of this polygon is the point 0, 4. This one is 4, 4. 5, 4, sorry, 1, 2, 3, 4, 5, 4. This one is 5, 0. And this one is 0, 0. I have to see which of these 4 points gives me a maximum or a minimum. Right now I'm asked for a maximum, so we'll do a maximum. So 0, 4, 5, 4, 0, 0, or 5, 0 gives me a maximum in the function 3x plus 2y. So I go 3 times x, 3 times 0, plus 2 times 4, and I get 8. I go 3 times 5 plus 2 times 4 and get 15 plus 8 is 23. I go 3 times 0 plus 2 times 0 and get 0. And 3 times 5 plus 2 times 0 and get 15. My maximum occurs at 5, 4 for a maximum of 23. Okay, kind of in the abstract doesn't make a whole lot of sense, but when we do the word problems tomorrow, it'll make a whole lot of sense, but then they'll be much harder. Okay, let's do one that's, yes sir. No, and sometimes we go for minimums, and so it's not always, it depends upon this function. If the if this was 1y and I'm sorry, 1x and 20y, would still that one would, in this case it would be. So you can't always depend upon it being that one point. So yes, ma'am. This function right here will be part of the problem, the word problem that we'll be doing. So you're going to have to figure out inequalities and an objective, and that's what we'll do tomorrow. Right? Today you're going to be given the inequalities and the objections, so you just graph them and figure out which one's the max. Tomorrow you'll be given actual situational problems where you have to figure out what the constraint function, the constraint inequalities are, and what the objective function is. So then it gets a little harder. Okay. X plus y is less than or equal to 8, has an x-intercept at 8, 2, 3, 4, 5, 6, 7, 8, and a y-intercept at 8, 1, 2, 3, 4, 5, 6, 7, 8, and I'll make my line, and I'm going to try to remember which way I would be shading because I don't want to get all my shading in the way. Oh, so 0, 0 is less than 8. 0 plus 0 is less than 8. So I'll be shading below that line. For my second function here, my x-intercept is 10 divided by 2 is 5, 0. My y-intercept is 10 divided by 1 is 0, 10. So let me graph those points. 1, 2, 3, 4, 5, 0, and 0, 10. Solid line again. Looking like that. And now that was a less than 2. 0 plus 0 is less than or equal to 10. So I'm shading below that. So currently my shading looks like below both of those lines. Currently my shading looks like right here. I'm sorry. Currently my shading looks like all of that right here. Okay? But I'm not going to put that shading in right now, because I'm going to go for my next two constraints. X is greater than or equal to 0 is a vertical line at x equals 0. Y, and I have to be greater than that, so I'm shading to the right. Y greater than or equals 0 is a horizontal line where y is 0. And I'm shading above that, so my shading ends up being this place here. Now, where are my vertices? They are at 0, 0,